Entonces now, okay, super. You immediately recognize que the genesis, o sea, the original function que come from the given, this is the given function, is the quadratic function, no? Okay, y equals x squared. Yeah, I know very well by memory que this graph look like that. It's a parabola, like that. By the way, this point, que is the vertex, is located at the point 0, 0, and the base. And the base, not in the origin, not in the given. So the second thing that you need to be aware is understand the transformation that somebody, not me, are doing in this function. Number one, we are doing this transformation. Somebody subtracting 5 inside the parentheses. And that means horizontal shift 5 units to the right. Yeah, I know get to the right because the negative. I proved the last class. Okay, so my new parabola after the transformation now is, we want to discuss in detail the accurate graphic in decimals after, no? Is the point that this, the original is 0, 0, now is 1, 2, 3, 4, 5. The progressive driven, the still join, the won't be interactive and listing. Okay. 5, 0, 5, 0, 5, 0. Entonces now the new graph should be complete. Okay. It's like that. So it's some student send me email that this parabola is moving to the right by using horizontal because the transformation is in x, not in y. So it's horizontal motion. What is the next transformation you guys can see? Well, the next transformation you guys can see is, well, you multiplication by -1 here. And when you multiplication by -1, it's obvious that the y value change. 1, 2, 3, 4, 5. It's again a 5, 0, but the negative here affect the y value. So any point is affected by negative sign. Therefore, the new parabola after the reflection look like that. Okay, this is reflection. This is the name of this is reflection about x-axis. Okay. And finally, I can see that we have minus f x plus minus 5, sorry, plus 3. This plus 3 outside affect only the y value. Therefore, this is vertical shift 3 units up. Because 3 is positive. 3 units up. Now my final answer look like that. Okay, remember 1, 2, 3, 4, 5. It's moving down, and after moving 3 units. Therefore, this famous point, okay, 5, 0 would be now 5, 3. 1, 2, 3. Okay, so the vertex of the final answer it look like that. Okay, this is roughly sketch. However, if you want to see clear, accurate, and detail, let's do it in decimal. So every student can use in decimals in the test. And remember, you send me no the graphic by hand in one graphic paper. No. You are doing in decimals, and you print the image in decimal, and you attach to the text, right? Okay, so now let's move on to decimal to see the idea. Okay, let me try. Okay, here, over there, I suppose. Okay, over there, I suppose. Okay. Okay, share the screen. Oh, what's going on? Oh, it's Desmos. Yes. Okay. Do you see Desmos? Do you see Desmos? You see? Okay.
Yeah.
Come on. Say okay. Okay. Look, we are doing the example 2. Let me activate. No, example 5. No, after example 2. Okay. The original function is this one. Okay. Let me. Espera, one by one. Activate one by one, but you see the transformation. This is the basic function. It's a regular parabola. However, the first transformation was x minus 5 that represent horizontal shift 5 unit to the right, bang. After that, reflection about the x-axis. And finally, vertical shift 3 unit up. Let me change the color. To change the color, guys, you click here, hold the mouse, for example, black one. And let's use the black color to represent the final answer. The original is black, the final is black, and the intermediate partial answer is another color that you prefer, blue, red. Any question? Any question? Super clear? Confusing? Clear. Clear. Okay, let me see. Let me come back again to the whiteboard. Boom. Whiteboard. Let's do it, example 3. Okay, let's analyze the piece of paper. No, complete. And here just in case it called attendance. Yeah. I try to check the attendance again. Pero no more matches. No interrupt me now, please. After when the class is over, I try to check in attendance again. Example 3. Example 3 is easy. Example 3 is easy. Look at that. Example 3 is okay. The function f of x is equal x minus 1 raised to the cubic power plus 7. Okay, so you determine first what function comes from this given function. I suppose esto is the collection of the most important function in college algebra. Y I understand that the basic function is a cubic function. The basic is y equal x cubic power. And I know the cubic power look like that. Look like that. Okay. Typical point 0, 0. Este es typical point. 1, 1 is typical point. And 1, negative 1. This is point. Look, 0, 0. 1, because 1 cube is 1. And negative 1, negative 1 is another point because 1 cube is 1. And negative 1 cube is negative 1. This is the x value, this is the y value. Okay, this is to get one reference, pero no necessary. It's just roughly sketch, qualitative idea, how it look like, and the transformation that I can see is, number 1, I can see that the function is affect x minus 1. I need to know that when the transformation is inside the parentheses, is again horizontal shift 1 unit to the right. Because it's negative, the number, no? So now my new graph is something like that. Okay, that point is moving to the right 1 unit here. This point is transforming like a 1, 0. It's important to understand that the y component stays the same, doesn't change, because the motion is horizontal. And horizontal only change the x. Okay. So now my function look like that. By the way, curiosity, just curiosity. This point now would be 2,1 because you increasing the x component because the motion is to the right. No? In this case, you increasing -1 plus 1 is 0. At that point, at the point 0, -1. But this is not important. Right? It's not strictly, mandatory because we can do in decimals after, right? It's our famous graphic calculator, free, beautiful, in color, available for everyone. And finally, plus 7. Plus 7 is fx minus 1 plus 7 is vertical shift 7 unit up, like the soda, 7 up. Okay? Now, my new graph, 7 up, increasing now, go up 7 units. So it's, suppose the famous point get 1,7 here. Now it would be 1,7 because the y value increases 7 units. 1, 2, 3, 4, 5, 6, 7. This point, get the point 1,7 is the transformation of this point get 1,0. No? Entonces my graph have the same shape. It's obvious, no? Have the same shape. No compression, no translation, no, it's the same shape, but it's only motion. Because at that point is the point 1,7. That point would be 2,8, no? I suppose, no? Because you adding 7 in the y component. Entonces that point gets 2,1 plus 7 in the y is 2,8, no? And likewise, this is 0,-1 plus 7 is 6. That point is the point 0,6, positive 6. And this is the idea. But just in case, to make sure everything is okay, we are doing decimals. We are doing in decimals. We try to switch in to share the screen for the decimals. Boom. 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 Boom and boom. Let me know if you see decimal or not. Okay, good. Now, you see now the example number 3, no? Number 3. This was number 2. Okay, close that. Number 3. Number 3, we have the original function. No, one by one. Wow. Okay, this is the, let me change the color to black. Okay, the original. Okay, the first transformation is, horizontal shift, 1 unit to the right. And finally, horizontal, no, vertical shift. Let me change the color to get black. 7 unit up, something like that. Okay. Suppose in the test, as you do the graph of this, you don't need to do it step by step if you want. No? Depende the question. Si the question says step by step, well, step by step. But if the question is find the final answer, well, entonces you omit this step and you omit this. And this is my final answer after the transformation. Any question? Okay, how do you get the original? Okay, good question, Mason. Okay, question, Mason asked me, how do you know the original coordinate of the, depending on the function. Let me try to share the whiteboard. Good. Switch into whiteboard. Okay, Mason. I try to explain for you now. Pay attention. Okay, specifically, and that function gets cubic, I take, of course, easy point. And easy, in my opinion, is 0, 1, and -1. So you're supposed to get this is x value. And y value for that function is plugging in here. 0 cubic is 0. That's 0 cubic is 0. 1 cubic is 1. And negative 1 cubic. Oh, I see. Okay, es negative. Ajá, entonces, y the point, guys. No 100, ni 300, ni nothing. 0, 1, and negative 1. It's a fantastic point. Easy to see. Well, when it's possible, sometimes, no. Okay, let's move on to the, wow. Now I'm moving on to the two, a little bit complicated example. Because so far, the example 1, 2, and 3 was easy. It was easy because, thank you. No, my pleasure, mate, so anytime. Don't hesitate to ask a question that you don't understand. The example 4 and example 5 is hard. Why is hard? Because the transformation is not clear. I call that non-explicit. Non-explicit form. That you don't see, or at least it's confusing to see what is the transformation. So suppose that function f of x equal, this is a classical example, square root 5 minus 6. Okay, I know. Okay, this given function come from for the basic function f of x equal square root x. Okay, I know very well that the graph look like that. Boom. Let me try Mason again one more time to discover three good points in this curve, x and y. 0 is obvious. Radical 0 is 0. Therefore, the point 0, 0 belongs to this. 1 is good because radical 1 is 1. So 1, 1. This point is 1, 1. And negative 1, no, because that function has no negative part because the domain of this function is only positive, or not positive, non-negative, just 0 or positive. We have no graph in the negative part. That's the reason. And you take no 2, no 3, I take 4, because I know very well that square root 4 is 2. Therefore, the famous point is a 1, this is 2, this is 3, this is 4, 4, 2. Bam, 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 this point is 4, 2. I have in my hand 3 points, 3 easy, important point. You want more? Okay, let me try 9, get 3. Let me try 4, get 16. The square root 16, sorry, 16 and 4, 16. This is increasing, but not increasing too fast. Okay. But this is not the problem. This is the easy part. I see off the basic function. Perfect. Thank you. Okay. Now, the complicated part. Pay attention, please. I try that somebody discover what is the transformation that we are doing in this basic square root to get that one. What do you think? Is horizontal shift, vertical shift, a reflection? I have no idea. I am totally lost because there's no implicit, no clear to see the idea. But try to you apply your best knowledge about transformation. What do you think? Opinion. I need opinion. I need opinion. Si no opinion, well, okay, no, I understand. You don't see what transformation is confusing to see. No idea. Okay, let me try. Let me simplify the thing. If temporary to analyze that, I ignore this file. Actually, we have that one, negative x. Oh, professor, this is reflection. This is replace x for negative x is reflection. Reflection reflection, but in this case about y axis. Remember, we have two kinds of reflection. We have the reflection, for example, the function when you put a negative here, or when you put a negative here. This is about x that we discussed in the last example, the last number in the second example, and this is about y. What means to be about y? Well. Okay, our let me use in green color like that. Okay, this is the graph of the radical minus x. You say, but professor, you delete the 5. Okay, I restore now the 5. I come back. But you have some idea that in the middle of the process, it's not super clear, but you see now that we have reflection. And suppose that this 5 represents horizontal shift. But I am not clear si es to the right or to the left. The professor say que when it's negative is to the right. The professor say that when it's positive is to the left. However, entonces you need, in this case, que es non-implicit. Non-implicit form. Non-implicit means not clear. It's implicit. You need to manipulate a little bit the function to see more clear. So I propose you factorization -1. -1. You open the parentheses and you have x minus 5. Let me see if this is equivalent to this or not. You apply distributive property, negative times positive negative, time, and negative times negative positive time. This is good. Now, in my opinion, I don't know if your opinion, I see more clear. We have one reflection F, reflection about y-axis. So now, because this minus here indicate me it's reflection. So basically, see, I do the graph. Let me continue using the red color. We are doing something like that. Push. Something like that. Okay, this is the image of this original is like that. No, I don't want this. Okay, this is radical minus x. And now you see minus 5. Oh, this is equivalent, so that was equivalent to change x for negative x get reflection. But now the second transformation is equivalent to say x minus 5. And x minus 5 is vertical shift, vertical no, horizontal, sorry. Horizontal shift 5 units to the right, no? Because I know the negative to the right. Okay, therefore, my function look like that. Okay, this point gets a famous 0,0. Now I move in 5. This is 1, 2, 3, 4, 5. And also don't forget the reflection that we're doing in the first step. My curve look like that. And this is this. And by the way, it's this because they are completely algebraically equivalent. Got it? Oh no. Just be careful. This is a classic example in the test in which you have a square root, but you have negative sign. So you don't understand very well es horizontal shift or reflection, or both. In this case, both. Okay? Let me show you in detail in decimals. Let me show you in detail in decimals. Okay. Anyway, boom, 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 boom. Do you see that one, huh? Okay, good. This is example 4. Let me try to expand. Look at that, step by step. No. Wait a second. Wait a sec. Let me do it step by step. Okay, and my basic function is a square root function. Look like that. The first transformation is negative inside is reflection. And I copy here both ways. The original. The second one is, no, it's more clear, in my opinion. No? So this is the original, but do you see the reflection and horizontal shift 5 units to the right? In blue color, and it's exactly equivalent to this one, but in green color. So you put both together, overlap, green and blue, you have semi-blue green color, no? Okay, let me try to. Okay, here is to change. Okay, you change here. You change the mode. Let me see. I don't know. Okay, I don't remember how. Okay. Do you follow me? Do you understand the? The thing I try to explain is, not always the transformation is evident. You need to do something algebraic, and manipulate algebraically the expression in another equivalent, and more clear to see the transformation. Okay, I have another example, que es non-explicit, but we manipulate in different ways. Okay. There you go. Switching the window. Okay, whiteboard now. Okay, this is our whiteboard now. Example 5. Example 5, you have that function is f of x. Guy, I always put f of x, but you can put, if you want, y, because you know very well que y and f of x is the same thing, but this notation, the function notation, allow me to understand the transformation and other thing that we study here, because you plug in here constant, variable, etc. So now, suppose this example is y. I want to put y, x squared minus 4x plus 5. Entonces, I know, at least I know, that the basic function associated with this given example is y, or x squared. But I have no idea si es horizontal shift, si es vertical shift. I am totally lost. Okay, because I need to manipulate this. It's not clear, it's not explicit. Now, let's do it. What is the manipulation? The manipulation is easy. The manipulation is similar to complete the square. So you suppose y is equal x squared minus 4x plus something. And this something is the magic number that completes the square. It's b over 2 squared. You know that. When you study circle, we do that. In this case, b is 4. Look at that. B is that 4. 4 divided by 2 is 2. Square 4. It's a coincidence that 4. So the fantastic number that we need to complete the square is 4. However, unfortunately, we have no 4. We have 5. Okay, to say, what should I do? Well, you break it down 5 and 4 and 1. Why not? It's a one possibility. You put plus 1. And now this expression is equivalent to this. 100%. Equivalent. Okay, but in this case, I take advantage. Okay, this is perfect square trinomial, and the factorization is x minus 2 squared. Wow! Now you see super clear what is the transformation. The transformation number 1 is fx minus 2. It is horizontal shift 2 units to the right. And the second case plus 1, well, it's vertical shift 1 unit up, down. That's it. Entonces my parábola, que I know que look like that at the beginning, con the famous point, in this case, the famous point, guys, is, let me show you, xy, 0, 1, and negative 1. I like that value. Always I can apply by using this. 0 squared is 0. That is a reason that that point is 0, 0. 1 squared is 1. That is the reason that that point is 1, 1. And negative 1 squared is positive 1 again. That is the reason that this point is the point negative 1, positive. And this is the graph, roughly, of my basic function. And the transformation was moving to the right, 2 units. To say 2 units to the right is, 1, 2, 1, 2, 1, 2. This is my new parabola after the transformation. The first transformation was transformation number 1, T1, represent transformation number 1, f and x minus 2. Vertical horizontal shift, 2 units to the right. If you want to transform at that point, well, that point is the point 2, 0. That point is the point, let me see, plus 2, no, 3, 1. Entonces this point is negative 1 plus 2 is positive 1. Entonces that point is the point 2, 1, 1. But this is not important. Finally, plus 1. Bueno, si es plus 1, entonces my graphic is like that. This is 1, 2. This is 1. This famous point is 2, 0 now would be 2, 1. Because the entire graph is moving up 1 unit. Boom. Something like that. Okay, this point now is the vertex, by the way, is the point 2, 1. And this point, que es 3, 1, would be 3, 2, no? Because you increase in plus 1 each y component. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 1 is 2 again. That point is the point 1, 1. Hello, 1. 2, 1 is this. This is not 2, 1. This is 1, 1, no? 1, 2. 1, 2. I guess so. 1, 2. Because the original point was 1, 1 plus 1 and the y component, because this one increasing only the y component. And this 2 increasing only the x component. That is the reason it's moving to the right. Charm. Okay. Let's move on to decimals to see more clear and more beautiful this transformation, and let's see the transformation. No. In the review, we go over it again in detail, Okay. Pero I am doing pero too fast. Okay, where this is the decimals. Okay, put it like that. Out. No. Wait a second. Sorry. Cancel. Switching to. Okay, there you go. I have decimal here. I suppose you see now. Yes or no? Okay. Therefore, do you see no? You see decimals? Yes or no? Good. So I see you answering the other laptop. Yes, Kemily. Kemily always help me. Now, as example 5. Look at example 5. Example 5 start to the basic parabola is this. This is my final answer. Let me change to black color. Okay, this is the original, the base, and this is the final answer. And this is how you go from the basic to the final answer. Well, the transformation is horizontal shift to unit up, to unit to the right. I'm using another color. It be blue. I like blue. And finally is 1 unit up. So vertical shift, 1 unit up. Bang. Okay, blue color. Okay, in this case they are coincidence, the blue color and black color. Okay, let me erase everything. This is the basic, the history. This is the, well, this is the partial transformation. Boom. And we have in black or in blue the function, by the way, is the same. Algebraical equivalent is the same expression and the same graph. Super. Okay, because I want to conclude that part. When there is one example que, in my opinion, summarize everything. So, summarize everything. Guys, if you want, when the class is sober, I send to you this script de Desmos. So I send the link. Es important que yo no understand que when I send the link, it's my gift for you. This is the copy of my work. However, you can delete, screw up, but no problem, because my copy stays the same, right? And you additional new idea, good, much better, and you share with me, no? Okay, so now the conclusion. The conclusion. I create here one example for the conclusion. It's a little bit interesting, but it's a little bit confusing. Look. Suppose that we have one segment like that. By the way, represent the function because it's a linear function, but it's a one piece of the linear function, no? It's a function because how do you know it's a function? Because when you apply the, for example, the vertical line test, pass the test. So, suppose I want to perform transformation. This segment is good to see any transformation because in another point, another function is not clear, but in the segment is super clear. Let me show you. Suppose que I change A. A is addition one number. Addition or subtraction, depending si es positive or negative. Entonces dice classical vertical shift. Look at that. So the blue one is the basic segment. The green is the transformation. The thing we're doing is addition 2, 1.5. Now subtraction is down. Vertical shift up, vertical shift down. So in this point, I want to emphasize the idea that the x component stay the same, however the y component change according to the number that you adding or subtracting. Clear? This is clear. Okay, I like that. Let me restore. Okay. Now, a similar idea happens when you change b. Okay, b is inside the parentheses. The function I call b plus b. Si es negative, wait a second, let me activate that. Si es negative, entonces es horizontal shift to the right. Si es negative. Y si es positive, es horizontal shift to the left. Okay, in that case, it's important to understand. For example, I put negative 1 here inside the parenthesis. B is negative 1. So now you see how the y component, the second component, stays the same, 5, 2, 2. However, the x component increasing plus 1 because B is negative 1. Suppose que es negative 2. Wait a second, negative 2. Entonces increasing plus 2, like that. Es 4 plus 2 is 6, and 2 plus 4 is 6. Si es negative, well, si es positive, sorry, entonces completely opposite operation. It's interesting how the operation inside the parenthesis look like different to the operation outside. Outside si es plus, es up. Si es negative, es down. However, inside the parenthesis plus is right, because it's addition. Sorry, minus is right. So in my common sense, maybe at the beginning say, well, minus is subtraction. No, it's addition. Si es inside. Okay, no problem. I understand. Now let me restore. I want to go to the like a stretching, compressing, reflection. Okay, it's when you multiplication, no addition, no, multiplication. Multiplication what? Multiplication the original function by one number. Okay, number I select here. Suppose multiplication by 1. Entonces no transformation, because 1 is invisible. Multiply. However, if you multiply by number greater than 1, look at that. What is the name of this transformation? Well, let me try to find one number not necessary decimal, suppose 2, and make a zoom to see more clear. Then the thing we're doing is multiplication by 2 outside the parenthesis. And when you multiplication by 2 outside the parenthesis, it's obvious that the y component is multiplied by 2 and the x component stays the same. So compare 2 points. This point in the basic f4,1 now will be 4,10. The x component doesn't change. However, the y component multiplied by 2. So this is classical vertical stretch. Suppose you see that, right? The effect, vertical stretch. However, if the c is the constant is less than 1, let me restore 1 again. 1 is no transformation. Suppose now I make it zoom to see more clear that c is less than 1. Suppose 0.5, 0.6, 0.7, and you see clear. And you see clear that we have the compress, horizontal compress. Okay, you see that the x component stays the same. However, the y component is reduced. Okay, reduced by, in this case, 0.4, f2 and 0.8. Well, okay, let's see. But you see effect clear, vertical stretch, vertical stretch is this, sorry. Vertical compress is this. And we continue for the negative value. Compress, negative value. Oh, reflection. Perfect reflection is when the C is negative 1. You see here, there you go. In which you can see clear like water. Okay, this segment is the image of this segment. So you consider that the x-axis behaves like a mirror image, and this is reflection about x-axis, and the thing that we are doing is multiplication by negative 1, but outside the parenthesis, Okay, let me restore. C is 1, no transformation. No, 0 transformation, no transformation. Because multiplication by 1 is nothing, no? Ahora, suppose que I multiply, but I multiply inside the parenthesis. The effect is completely opposite. Not exactly opposite, but it's different. So when you multiply by d greater than 1, suppose this. Let me activate the transformation. When you multiplication by greater than 1, suppose 1.2, 1.8, 2. Okay, the effect was the y component doesn't change. It's clear because I am multiplying the x, not the y. However, the x component is divided by 2, not multiply. It's divided by 2. The effect is completely opposite. What's the opposite operation of multiplication? Division. What's the opposite operation? The addition, subtraction. You see, when you manipulate, multiply or adding or subtracting inside the parentheses, the effect is opposite. Entonces, ¿cuál es the name of this transformation? Bueno, I suppose que the name es compress, ¿no? Es horizontal compress. Compress o stretch. I suppose que es compressed, ¿no? Es compressed. Well, I don't know. I suppose que es compressed. Let me see the opposite effect, and maybe the opposite help me to understand if it's compressed or stretch. Suppose D now less than 1. Uy, look at that. Es obvio que es stretch. Horizontal stretch when the D is less than 1. And when the D is greater than 1, es horizontal compress. Compress horizontal, stretch horizontal. And what about negative? It's going on to the negative. Negative. The perfect reflection is when it's negative 1. Oh yeah, look at that. This is a perfect reflection about the y-axis. And this is like an image of this with respect, so under the consideration that the y-axis behave like a mirror. Super clear or super confusing? Now, transformation. Let me know. We need to practice. I understand. But you get the theoretical part clear, no? Of course, you need to memorize this. Some rule that I explained in the last class. Try. Here, over there. Switching to the whiteboard. Okay. Now, we are discussing now another completely different idea. Transformation is over. Moving on to the combination of the function. Okay, there you go. Boom. Combination of the function. I think we try to study now is we have two functions or three functions. I don't know, never three, two functions. And we combine like that. Using, for example, you have the original function is given f of x. No red color. Okay. You have f of x and semicolon, g of x. If you combine using different arithmetic operations, sum, difference, subtraction, differences, multiplication, product, and division, quotient, division. For arithmetic operation, adding the function, you subtracting the function under the supposition that f is the minus hand and g is the subtrahend or opposite, whatever you want. Now multiplication, f of x times g of x, and the division. Division is f of x divided by g of x. Oh, this is not new, this is clear. However, you need to be familiar with this notation. Okay? The addition you write like that, parentheses, f plus g of x. This denotes that this function, new function, come from for the addition to original function is f and g. This is subtraction. This is multiplication, period. And this is division, f division g. This is new notation, convenience notation. Now, what about domain? What about domain? So you know that the domain of f is you know, is given, and the domain of g is given. Entonces, the domain of the new function, domain f plus g, is the intersection, domain f intersection domain g. What means intersection? The common value in between this domain. I suppose that the domain of G is this set, symbolical, you know, and domain of the other is like that. And this is what is the domain of the new function get the combination. Well, the domain is this one, intersection. Okay? Because it's the value that both functions share and to be not undefined. Because you pick, for example, you pick one point here. Okay, suppose this is domain of F. This is domain of G. You pick one point here. It's okay for G because it belongs to the domain. And you pick one point here. It's okay for the F. But this is okay for the F, but not okay for the G. So what is okay in both here? Anyway. And this repetition the same. Domain of the subtraction is the intersection. And domain of the multiplication, again. And domain of the division, no. Domain of the division is different. Because domain of the division introduce new restriction. Remember, division is always complicated. Because it's the domain of F, intersection, domain of G, but introduce one restriction that G X such that G of X gets the denominator part, no zero. So you need to identification some value in which the denominator is zero, division by zero is totally illegal, so no good. Okay, let's see example to understand more clear the combination of the functions, or at least the first part of the combination of the function, because we have the second part. The first part is the easy part. Let's move on to example. One example is long example because it includes addition, subtraction, multiplication. Suppose que is given two functions. Two functions is given. The first function is 1 over x plus 3. Semicolon, and G is of x is x over x plus 2. By the way, I want to, well, no, okay. You find what? You find the function f plus g of x using this new notation. You find f minus g of x, comma. You find the multiplication, f times g of x, and you find the division, f divided by g of x. Entonces you find the expression that corresponds with this new function, and also state is domain. This is important. Stays there domains. Okay, because when you define one function, you need to state the domain. Okay, easy, no big deal. I go to the addition. Addition is you adding f plus g of x is 1 over x plus 3 plus x over x plus 2. And that's it. Well, yeah, yes and no. You can leave it like that. But no. I like you condensing in one expression. No? Find the least common denominator. It obviously is x plus 3, x plus 2 together. Entonces when you divide by the first denominator and multiply by the corresponding numerator, stay x plus 2. You suppose that you know that, right? Plus x times, this x is this, x plus 3. And that's it. No. You apply this trick with the property, why not? And combine like So now the elegant, this is just elegant way. So you leave it like that, it's okay for me in the test. However, this is more elegant, you know. You know, the algebra have a specific style. X plus 3, x plus 2. You have x plus 2 plus x squared plus 3x. And we combine like each other. We combine and organize in descending order of the degree. X squared first, x plus 3, 4x plus 2 divided by x plus 3, x plus 2. You say, maybe, Professor, you apply 4 here. Well, you can. But in my opinion, this is very, very acceptable expression. And that's it. No, because I need to define domain. Domain of what? Domain of the new one. To find the domain of the new one, well, I need to know the domain of the original, domain of F, and domain of G. And remember the lecture, okay, I explained the determine the domain with the equation. In this case, is division, P divided by Q. I suppose you remember that, P divided by Q. We need to find the value in the denominator, case Q. In this case, x plus 3. You take that expression, look. You put it equal to 0. You in one corner of the piece of paper, you put x plus 3, non-zero, okay. Therefore, that means x is non-negative 3. So the domain of this function is all real value, all real numbers, sorry, and no negative 3. Because what happened in negative 3? I know that negative 3, when you plug it in the function, so f and negative 3, look, f and negative 3, you put 1 over negative 3 plus 3, and negative 3 plus 3 is 0, and division by 0 is totally undefined. Undefined means error, mistake, and it's totally out of the domain. Likewise, similar, in domain of G is the this expression, entonces you put es negative 2, ¿no? Entonces es x such that x no equal negative 2. And entonces, what is the domain of the new one? Bueno, I studied que es the intersection. Is this and this together. O sea, the domain of this is all real number. It's all real number, except the bad guy. Who's the bad guy? Minus 3 and negative 2. Doesn't matter the order. Well, but in the test I like, you express this not in English. You express it in always interval notation. Okay, in the test always 100%. I want this notation. So now to understand this in interval notation, look, I put my famous all real number line. Positive infinity, negative infinity, 0 in the middle. Yeah, I know that function have a hole in negative 3 and negative 2, negative 1, negative 2, and negative 2. We have here one hole in negative 3. We have another hole in negative 2. And the domain is all real number, boom, boom, and boom, except negative 3 and negative 2. Therefore, we have parenthesis here, parenthesis here, parenthesis here, and parenthesis here. So the answer is the domain of this function is equal from negative infinity, comma, minus 3 parentheses, union, minus 3, comma, negative 2, union, minus 2, comma infinity. que es the same, it's equivalent to say all real number except because we have the entire all real number line except que -3 and -2 we have one couple of the wholes. Wholes is the bad guy. Similar idea. I don't want to repeat this because it's the same stupid thing. Subtraction, multiplication, and division, no. Division I need to do because division have a special restriction. And division, let's do a division. Division is, suppose that I put f division g of x. I know. I put the function f in the numerator. Put the function g in the denominator. Actually, in our example, it's 1 over x plus 3 over x over x plus 2. And also we have a complex fraction. And as the complex fraction, in this case, you put 1 over x plus 3 times, and you flip that, x plus 2 over x. And you see now how we introduce new idea. Look, this is x plus 2 over x plus 3 times x. So now what is the domain? Well, the domain is similar to this, except that we introduce one new bad guy, que es 0. Entonces es 0 also es paréntesis. 0 is also the whole, because you plug in 0 here, division by 0 again. We have one other whole here. So the answer in the division is, answer is from negative infinity, comma negative 3, union, from negative 3, comma negative 2, union, from negative 2, comma 0, paréntesis, union, 0, comma infinity. Entonces, maybe the question that you have is, bueno, professor, pero what is the reason que negative 2? Because negative 2 and the original equation is in the top, not in the bottom. It's not only negative 3 and 0. No, because when you suppose that you plug in here, this is, remember, this is the equivalent in between quotation mark, but after the transformation. So you substitution negative 2 here, you introduce negative 2 plus 2 as 0 is undefined in this moment. Okay, because you continue the idea that the domain is the intersection, pero yo incluye one extra restriction que es the new denominator que appears when you are doing the division. Okay, in this case, in this case, everyone follow me? Why do you go subtraction or multiplication again? Bueno, okay, pero ese es the Clifford. It's the same stupid thing, no? Or no? Okay, well, okay, let's do it. What do you want I do? Multiplication or subtraction? In my paper, I have both, but I suppose it's the same. No. So you say que I do. I do or no? Clifford? Holmes? No, he said no. Okay. Let me go to the super important part. No complicated, but it's a little bit complicated. Que es the composition. Okay? Composition. Composition of the function. So we are doing combination. But now composition. Composition is a little bit more abstract, a little bit more complicated. You have, for example, composition. Okay, what is the composition? You have two functions again. Suppose f of x and g of x. I want to perform composition. Composition is like a, for example, and the notation that we are using, you need to be familiar with this. F composition G. This look like a 0, but actually it's not 0. It's a symbol. It's indicate composition. Okay. Or why not? Why not? G composition F. It's extremely important, the order, because this order indicates us. Okay, G in this case is the first function. Entonces, bueno, okay, es the first. I don't understand. Bueno, okay. The problem is que that function, que G is the first, and go directly inside the argument of the function. This is equivalent 100% to say F bracket G of X like that. The one function inside another function. This is not new for you. This is not new for you. Suppose when you are doing this, x squared, and for example, y equal x minus 2, and you are doing the composite expression go inside this, x minus 2 squared. And you have a composition. You have the linear function inside the quadratic function, and you form a new function. In this case, it's different. In this case, I assume f is the first function according to this notation. You need to be familiar. And G is the second, and F is this first. Let me try to understand using one elementary example. Suppose you have the function f of x is equal x squared plus 1 plus x plus 1. This is given in my test. And g of x is 2x plus 3. Okay. And the test I asked you, determine the expression of the F composition G. Well, okay, I understand. I understand in this notation that G is the first function. This is the first function. And this completed function go inside the F. Here, you replace x for 2x plus 3. So you copy now 2x plus 3 squared plus 2x plus 3 plus 1. Because the last part is just a constant, have no x. So basically, I take the green expression and replace in the second function for x. And leave it like that. You can leave it like that, or you can manipulate. Let's do in manipulation. For example, you foil this 2x plus 3 times itself is 4x squared. This time this time this is 6. This time this is 6. It's repetition because they are two in plus 9. Plus 2x plus 3 because I remove that parenthesis because the number that I suppose here is invisible 1 plus 1. Leave it like that? No, hello. You combine like this. 4x squared plus 14x. Where come from 14? 6 plus 6 is 12 plus 2 is 14. Plus 13. No? 13. Where come from 13? Yeah. It's 9 plus 3 plus 1. 14. Boom. Final composition. In that order. I want to illustrate very well in the time we have that the composition is no commutative in general. So F composition G in general no, in 99% of the case is no G composition F. No, never. Well, never, no. There are some particular examples, yes. Can you see in the chapter 4? No, now. Okay, now, suppose que the professor asked me in the test, no, computer, please, G composition F of X. Well, entonces it's different. Let me copy again the function to understand much better. X squared plus X plus 1. G is 2x plus 3. Entonces I suppose que the first function que es f en the composition que es this. Go inside G, the argument of G. So this function, totally the green, go here. It's easy because you have only one x. So what is the answer? The answer is 2 times something, no x anymore, it's x squared plus x plus 1 plus 3. Leave it like that one? No. At least distribute the property, 2x squared plus 2x plus 2 plus 3 is 2x squared plus 2x plus 5. And you see that this expression and this expression is totally different. No commutative, right? No commutative. Entonces, what about, professor? The domain. Well, domain is a little bit complicated. Because the domain, okay, because the composition behave like a chain. Why change? Because you have a chain of functions. Look at that. I suppose in my mind that the function look like a black box. This is the G first, and this is F secondly. Any value inside the domain, go first for G. Any value of the X, is domain. Domain, remember, is a set of the X value. And the transformation of the Y behave like an X in the second box, and you get the definite Y. This is the final Y. So what about domain? Well, domain is easy. Domain of the composition, domain of the F composition G. Remember, guys, this new notation that we are learning today. I warning because the student don't believe in this, and the student believe that this is equivalent to say multiplication. This is period. This is multiplication. This is composition, que is 0. The domain of the composition is equal. The domain of the first function is G. Intersection, domain of the new expression. What is the new expression? Well, the new expression is the new expression that you obtain when you put together this and this like a 1. In this case, this example, maybe, no? In this order, maybe. Or this example. You have no time to continue. Next time, I promise we are doing one more example of this and we start review. By the way, do you see the document I sent to you in this email? 4 document? This is the review packet, okay? For the test tube. Silvana. So this is the review packet, guys. Don't worry, be happy. We are doing step by step. We dedicate one entire week. No entire week, but we dedicate